Welcome back. This time we're looking at chapter 3.2, basic differential rules and rates of change. We're looking at several problems. So at this point we're looking at problem 61. This is determining the points or point, if any, at which a graph of the function has a horizontal tangent line. If you recall, the actual definition of the derivative of x to the n power is equal to n minus 1. So basically we're subtracting 1 from the power and we are multiplying by that power times the leading coefficient. So let's try to do that again. Here we have the derivative of, in this case, y, which is in terms of x's, is equal to, you have 4x to the third power minus 4x, and then we have a plus 0 because it's a constant, but we really don't express that. So that's our first step. Second of all, because we're looking for horizontal tangent lines, keep in mind just the derivative itself of a graph. Let's say, for instance, let's pretend that this is the graph. Based on the derivative, we can find the slopes at certain points. Let's say here, maybe there. Right, but in general, because we're looking at the horizontal line at which the graph has a tangent horizontal line. So at this point, we want to know where this graph is equal to 0, our derivative. So that is a tangent line, and that will be a horizontal. So basically, we want to know where our slope is equal to 0. And the equation that we have here, that is our slope equation. So let's try to find out. So we have 4x cubed minus 4x is equal to 0. We can factor out a 4x from both sides. We have an x to the second minus 1 equal to 0. We can come up with two different factors. We have 4x is equal to 0, and we have x squared minus 1 is equal to 0. So from this point, we can analyze and say that we have a division by 4 here, and that crosses out my 4 here, and I end up with x equal to 0. Now on the other hand, for my x squared here, we can add a 1, we end up with x squared equal to 1. We take the square root, both sides will get x equals plus minus 1. So our final solution will be x is equal to 0, comma, positive 1, comma, negative 1. There you go. And so if we look at this graphical interpretation, once again, based on our highest degree, we can tell how many concave curves we have. So concave down, concave up. So in this case, it's a 4 degrees, so that will be 4 minus 1. That equals 3. As you can see, 1, 2, 3 there. So here's the actual graph. Right at x equals to negative 1, at x equal to 0, and x equal to 1. That is exactly the end result that we came up with. So x equals 0, 1, and negative 1. So let's take a look at, so basically what it's saying is that we have a slope that is 0, and of course we do have a slope that is equal to 0. Let's take a look at the next example we have. So this is problem 63, y equals to 1 over x squared. And here we have the definition for power rule. So at this point, I'm going to rewrite it. So I'm basically bringing in the x as a negative power. So when I do take the derivative of x to the negative 2, we get negative 2x minus 2 minus 1. And therefore, we get a negative 2x minus 3. Same process, we're trying to find out where this graph has a horizontal tangent line. And if we do the calculations, we have -2 on the top. We need to equal that to 0, by the way, and that's equal to m. So -2, then we bring the power down x to the power of 3, and it becomes positive. We get a 0 over 1, which is still 0. When we do cross multiply here, I'm going to change color here. So when we cross multiply, we get -2 is equal to 0. We know that that's not true, therefore we don't have anywhere in the equation, we don't have any points that equal to 0 like we did before, just like I'm showing here. Now let's take a look at the graph, and as you can see in the graph, we don't have anywhere in this graph this is y equals 1 over x squared, and in this graph we only have an asymptote, which is basically this asymptote here, and also we have another one down here. We're simply hugging the lines, but we don't have an m equal to 0. Okay, well, thank you guys for watching. Stay tuned and don't forget to subscribe.